how this is working, just for the folks at YouTube, we'll just do that demonstration one more time. So we're going to change it so that when we press the up key, we don't just move and then when I let go, you stop. When you press the up key, you're going to like increase your velocity, which is symbolized by the green arrow. And then we're going to have a separate vector for our direction. The direction vector will get added to velocity whenever we press the up arrow, so we'll start kind of moving in that direction, and we can kind of counteract things, and all sorts of fun can be had. I kind of like illustrating the vectors, but that's not going to be required. You guys can experiment with that. There's all sorts of fun mistakes we made in last block trying to get those visualized. It looked really weird and funny. But here we go. Here's the new story. So check it out. Check out my 3 vectors. Location is the same story as it's always been. Nothing's going to change there. It's really just an X and a Y, location. Nothing really exciting about location, to be honest. But now look at this. We have a direction and a velocity. So direction is going to represent what direction our spaceship is pointing, and velocity is going to represent the speed at which our spaceship is moving. Yeah? Yeah? All right. So what those do is coming up in a second. So first of all, first change, we're going to go to your constructor, and we're going to be changing... Oh, actually, I guess I'll show you how I'm initializing these things. Direction, I'm initializing to be a very small vector. Feel free to make this larger, but watch what happens if I make this larger. Like -1 does not seem particularly big, right? But I'm going to be adding that onto velocity. Look how fast I go. Whoa, I just like immediately start going so fast. Like, it's very hard to control this ship. It's very maneuverable, but like you need like some sort of AI pilot to make this spaceship happen. This could be changed based on difficulty setting. Maybe if you have easy, medium, hard, like you could change sort of the sensitivity of the thrusters. But for now, while I'm trying to figure it all out, I'm going to keep this to be a pretty small, like this tells us the length of the vector. We're going to have a small vector. Its direction is really all I want right now. And so it doesn't really matter how long it is. It can still rotate just like any old vector can rotate. And check out my velocity vector. It's 0, 0, kind of looks like an owl. Woohoo! And the whole point of this is I'm not moving at the beginning, so it's going to be 0. I can now rotate separately from my speed. Behavior functions. Don't worry about this is where I'm drawing the vectors, so don't worry about that too much. I now rotate the spaceship within the push and pop matrix using direction.heading, not velocity.heading. So the speed at I'm moving and the direction in which I'm moving is separate from the direction in which my spaceship is pointing. So that's going to make one change. And you can see that illustrated pretty well in the little thing here. Oh, I guess I'll just restart it. Remember, direction is the red one, right? See that? Direction is the red one. So I could be moving in this direction. The velocity is green. But my direction is different. It's a different vector. So that's why the red line here, the direction vector, is controlling my movement. And it has nothing to do with velocity. Velocity doesn't control which way I'm facing anymore. How you guys feel about that? Feel good? Yeah? Everybody okay with that? Great. So how do we get this sort of infinite movement thing going on? Check it out. That's the teleporting. I'll talk about that later on. It's actually pretty straightforward. Here it is. This is the story right here. Actually, let me delete these if statements. I don't mind to show you them, but I just don't want to talk about 2 different things at once. So here we go. This is my act function. Remember, act is happening every single frame, right? Every time in the draw frame and the draw function, we're calling act, 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 act every time, every 60th of a second. And so this is going to happen every frame. We're going to add velocity to location. That's what moves our spaceship now, when we add the velocity vector to the location. When we start off, velocity is 0, so adding 0 to things doesn't do much, right? So it doesn't move, but we can change velocity, and then velocity will constantly be adding to location over and over again. That's why we get this sort of situation where I fire the thrusters, and I'll just move forever in that direction. it'll just keep on going. Oh, I deleted my if statement, so it just goes off into infinity space there. I could fly back, I guess, eventually. Oh, that's gonna go too fast. This is too hard. I'm not gonna try. So this is what now moves me constantly. It's not in an if statement anymore. But what is in the if statements? Check it out. My left and my right keys now rotate the direction vector. So I can rotate my direction, and then when I want to fire my thrusters, I add the direction to the velocity. So now I can change velocity by adding my direction vector, which will push me in that direction, or at least change my velocity in that direction. So these lines, by the way, are exaggerated. That red line is multiplied by 500. So this line is like many times longer than the actual direction vector. So when I press the up arrow, I start moving in that direction, right? There's my green line represents my velocity vector. Also exaggerated. Oh, I really got to bring those if statements back in. Hold on. Here, there. And I'll just scroll up. Here we go. Yeah, so here is my up arrow. I say velocity.add direction. So whatever direction I'm facing, when I press the up key, that's why I start moving in that direction. I've added a bit of my vector or some of my vector onto that. If I keep on pressing the up key, I'll add direction over and over and over again, and that will get longer and longer, so I'll go faster and faster. So I can keep on going in that direction. See how I'm holding it down, and see how the green line is getting longer and longer? I can go the other way. I can add on the direction vector, and because I have existing velocity, it'll sort of add and subtract onto it, and then go the other way. See how that works? So I'm really just adding one vector, the direction, onto velocity, and then always applying velocity to location. Always, always, always. And then if you go sort of at 90 degrees, it adds a little bit differently, because if you've done Physics 11, and I don't know if anyone has in here or not, but if you've done Physics 11, you know vectors add head to tail. So it's like I'm adding this red line onto the green line, and I get a new vector. So it kind of like makes it go off in a different direction. It's not perfect. It doesn't quite go in the right way, but it sort of kind of turns around. And this is actually like Newtonian motion. This is like the way it was meant to be according to how physics works. I mean, not exactly, but like pretty close. And it gets pretty realistic movement. You can sort of see how you could get like at least realistic video game physics kind of movement. Get some nice kind of drifting you can do to drift around asteroids and things like that. And I think that works out pretty well. So I invite some questions. I know my last block had lots of questions about it. What do you guys think? How can I help you understand what's going on? What is still not clear? Does it make sense? What's the difference between direction and velocity? Yeah. So direction's all about controlling how the spaceship looks, so you're pointing in the right direction. And it's also what you can control when you turn the spaceship left and right. When you press up arrow, you add the direction vector to the velocity, which changes your velocity in that direction that you're facing. And so velocity increases. And if you're facing the opposite way of the direction you're going, then it'll actually decrease your velocity, because you always add head to tail. So hear me, I'm pressing up arrow. There's my green arrow for velocity. I can go the other way and make it go opposite. So when I'm pressing the up arrow and you see this changing, that's because I'm adding direction to velocity. I'm always changing my spaceship's coordinates by this vector. And when I press up arrow, I can change how that vector looks by adding direction to it. And you can get some good stuff going on. Maybe I can get it to stop. Oh, so close. Almost stopped. I'm not going to try anymore. So try and get that working today. The other thing I'd like you to try to get working is the looping, right? Where you go to the top part of the screen and you teleport to the bottom part of the screen. That's a pretty classic, video gamey thing to do. Every old school game kind of did that. Pac-Man, Asteroids, so many different types of games were like that. So the story behind that is just a series of if statements. You can just say, hey, if your x coordinate has gotten too big, like make it equal to a small number, like to like 0 or something. If your y coordinate has gotten too big, make it equal to 0. If it's gotten too small, make it equal to the height of the screen, and so on. I'll give you a glance at mine. Mine are a little bit kind of more complicated than they need to be. But basically, I'm just checking location.x to see if it's less than a number, a minimum number. And then if it is, that means I'm off the left of the screen. So then I just set it location.x to some number that's on the right side of the screen. And I'm using like ship size divided by 2 and width and stuff, just so that I can change my spaceship size and all the math will still work, but no requirement to do that. Same thing with location.y, same idea. If your y position is going off the top of the screen, send it to the bottom of the screen, is basically how that works. I wouldn't type this down because you're not going to probably have ship size and you don't have to do it this kind of way. And don't sort of like, I don't want anyone to like madly type it down and be like, I have to like absorb these pixels into my retina, or I won't be able to do it, because I want you to be able to like try that out. I know that's totally within your ability. Just checking, and if not, that's okay. Like, then you should probably ask a question about it, right? So just to give you an idea that it's really not that different than just sort of the if statements of like bouncing our ball on the sides of the screen. It's a little bit different, but not a whole lot of difference. And try it out. You'll probably make some mistakes as you go today, so call me over if you struggle making this work. You can get this working though. Fabulous! That's exactly where we'd like to be by the end of class, if you can make it happen, because then next class we can make our asteroid spaceship go pew pew. And that's always the best of all realities. Yeah, Justin, thanks for your question. No question? Okay, sorry. Misunderstood. Anyways, I'll stop the video. We will call this good for